Hi, and welcome to the 10 square metre workshop. Do you use a track saw, especially on an MFT, a multifunction table? Then you need to watch this video. But a word of warning, it may damage your beliefs. Coming up after this.
Here is an advert for a precision ruler made from aluminium. In the small print it tells us assured to 0.001 millimeters per meter. That is 1/1000th of a millimeter per meter. In other words, 1 part per million. Very accurate? One problem. Aluminium expands by 24 parts per million per degree centigrade. That means a temperature change of 4/100ths of a degree destroys the claim. You or I would have difficulty in measuring temperatures to that accuracy, much less maintaining our workshop to that level.
Well, they're lying to us. Probably not deliberately. The problem is they're not trained engineers and don't really understand the tolerances involved. Experienced woodworkers appreciate a good table saw. It will, almost certainly, have a cast iron top, cast iron trunnions, large bearings, and be driven by a smooth and powerful induction motor. Cast iron is heavy, expensive and prone to rust. Nevertheless, it's still preferred to cast aluminium alloy because it is more accurate and stable. Hang on a minute. We're using a saw made from aluminium and plastic on a thin aluminium rail on a wooden table on which we are relying for accurate cuts. What's going on? Wood, like any other engineering material, has properties that affect its useful purpose. It's well known that if you bring an old piece of furniture into a modern central heated house, it will move. It will show cracks, gaps. It is shrunk due to the lower humidity. Wood expands and contracts along the grain with changes in humidity more than across the grain. This makes movement more obvious. Note that a finish on the wood, varnish, paint, whatever, may slow it down, but it will not stop it. Particle board like MDF also moves with moisture, but being homogeneous it does so more evenly, so it's less obvious. By the way, don't get confused about the term waterproof when referring to MDF. This is not the particles themselves, but the glue. It just means it won't come apart when the glue dissolves, but it still absorbs the moisture in exactly the same way. So how much does it move? Well, manufacturers don't tend to publish this sort of data, but there's been research into it, and the data is published.
It varies a little bit between types, but it's typically given as 0.023% per 1% change in relative humidity.
So what does that mean? Well, if you have a 10% change in relative humidity, which is not huge, then an 1100 millimeter table will move by 2.5 millimeters. You might find that a bit surprising. Even more surprising, once it's moved, it doesn't return by exactly the same amount. It varies, but it won't be the same. That's just one of the elements affecting the material. Have you ever lent a piece of MDF against the wall for a few weeks, and when you come back it's bent like a banana? If you bought your table, did you ask the supplier what humidity it was made at? If you made it yourself, did you store it in your workshop for a year before cutting it? Then there's the accuracy of the table as made. One designer of jigs to cut a table made a claim in a video of accuracy that amounted to 0.01 millimeters across the width of the table. I calculated that holding one ruler longer than another so that it was 3 degrees warmer when the cutting of just one hole would destroy that accuracy. More than that, it involves drilling a lot of holes. A 3mm drill is used in a bushing to drill through the holes. Is the drill and the hole both 3mm? Now, if you've just seen it isn't. The drill dropped through. If they were both the same size, exactly, you'd have an interference fit. This would cause friction, which would build up. The drill would heat up more than the block because it's smaller, so it would expand, and that would increase until you got a friction weld. A small gap, a tolerance, is essential. A buyer of this jig system complained to the supplier that it didn't produce a table that was as accurate as he was expecting. The reply listed 10 tolerances like this that all add together, multiply across the table, and completely disavowed the accuracy that was claimed. CNC cut holes may be better, but they're still not perfect. Widely claimed to be accurate to 0.01 millimeters, a 5 centigrade change in temperature on a 1 meter machine will double that error. So MFT tables, especially MDF ones, are not as accurate as you might think.
It's worth noting that the first example of this, the Festool MFT, does not use the wood for referencing the fence or the rail. They're both referenced to the aluminium frame. The holes are only used for clamping. I suspect that this is not by chance.
So is the problem MDF? No. Using a good quality ply helps reduce some of the problems, but it doesn't eliminate them. Is this important? Not in itself, because the material being cut will also move over time, of course. The wide use of tables of this sort show that they're good enough for the purposes to which they're being used. In other words, they are accurate enough, just not as good as the boosters say. I myself use Baltic ply and cut my template on my CNC machine that I calibrated and squared just before cutting it. I finished every hole with a 20mm engineering reamer. Does that make it perfect? Nope. Just a bit better. I understand the factors involved and accept the resulting tolerances. My table's been in my workshop now for a few months and currently reads 19% relative humidity. The ply walls of my workshop read 13% humidity, so the table is still drying out and will still move a little. But that's okay. If a task requires more accuracy, I will use a different or modified method. That's engineering. But it's fine for the uses I put it to. Well, I hope you found this interesting, maybe even informative. The thing to take away with it is it's not necessary to fret about unnecessary and impossible levels of accuracy. It just has to be suitable for the purpose to which it's put. See you next time.